Hello. Uh, we live in the time where it is important to know how your space is being utilized if you are building and business manager. And whether you want to optimize the energy by optimizing your heating or cooling systems, or you want to schedule the perfect cleaning time for your space, or maybe you just want to reorganize space and improve your service quality. At the heart of such a system lies AI. And we developed a computer vision system which has a sensor, fisheye camera attached on the ceiling, and it records people, and the video footage is being processed in the real time. We apply object detection, object tracking, and we are calculating the interaction between people and the assets. All these crazy private invasive information ends up being just a bunch of numbers on some charts and dashboards where we want maybe to know how many people there are in the space or how long they are staying there, what type of equipments they are using, etc., etc. And since we are processing the videos in the real time, we also want to have notification system. Did you know that 1 out of 22 people are crime victims in some certain areas in Bronx? And people, they're doing drugs, they're whatever, they're gathering inside the building halls and in the front of the building, making it hard for actual tenants and people to pass near them because they are afraid. How can this system help in this case? We deployed this camera sensor in one of the buildings in the Bronx, and the goal of the system is to detect when someone stays for a longer period of time. If someone stays for X amount of minutes, we take the screenshot, send it to authorities, and then they can act on it. Basically, we don't want people to loiter here. Also, we don't want people to loiter at the front of the building. And in just a few weeks, we managed to reduce the number of alerts, meaning that we successfully cleared this space up. Well, we don't want people to loiter in the buildings, right? But also, we don't want them loitering at the empty front desk in the reception hall in the hotels. Statistics says that waiting time at the empty front desk above 30 seconds is considered a low quality standard in the hospitality industry. So how can this system help here? The system has been deployed in one of the hotels, and it's same. It's tracking how long people are waiting there. And if someone waits for a certain amount of time that is longer than, for example, 1 minute or so, we send a notification to the attendants so they can provide a quality of service. I'm sure we can go on and talk about all potential use cases and what we did and how everything looks nice now. But I would say that it wasn't always that easy. It wasn't always that cool. The journey itself that produced such a complex computer vision system was a journey to hell and back. I'm sure you all know that a single project that took a part of your soul and made you what you are today. And I'm talking about constant retraining after retraining, chasing ghosts, bugs, patching after patching, fixing, circling around, experimenting, and all that goes in vain. And is it good to mention that you're working on a startup that needs for investment, and stakeholders are angry, and panic starts to creep in. There is a despair and all kinds of bad emotion. So we as development team, after several months of torturing, we went to a nearby place to have some burgers and beer. And we also asked one of our dear friends to join us and spare a few wise words. After a couple, too many beers, I would say, he slammed his hand on the desk and said, "You guys need a hero, someone that will do what is right because it is right." And we all felt inspired by that. We all wanted to be heroes. We all wanted to work additionally just to prove something that we wanted to make it work. So we sit during the weekend, did our job, and did our best, in fact. The judgment hour, Monday, call with the stakeholders. We presented what we have done, and the reality was we were burned at stake. So the question was, who told you to do this? We just need some short fix. We don't need AI for this. We don't want to improve this. We want to improve that. How can you test it? How can you prove that what you made actually works okay? We didn't know the answers for that. We just wanted to put the project out of the misery. So, but it proved an opportunity for improvement. There were some hard weeks after that, but there was a hope, because at the end, what is the most important step a man can take? It's not the first one. It's always the next step. And our next step was to introduce the MLOps that as something that can fight the pestilence that spreads through the ML projects. We can, in a plain words, we can say the MLOps is just a bunch of processes and automations that brings order from the chaos in ML world. When building an ML system, you usually depend on three things. The first thing is code. Well, if you change the code, you will change the model as well. So you need to make sure that your code is properly versioned. You also need to apply some CI/CD pipelines, and we can call all of this as code operations. The next thing that your machine learning model depends on is data. You change the data, you will probably change something in the model. So all of these things, how the quality of data, where data came from, data set versioning, and all of this, we can call it data operations. And in the end, there is all story about the model lifecycle as well. You change some hyperparameters, you want to register your model somewhere. You also want to have ease of deployment, inference, monitoring, and everything other that goes with the model itself. And we call that model operations. How does it look like in our pipeline? Basically, we have some sensors that constantly uploads the video footage to the AWS cloud, and we have some inference pipeline that take these videos and then apply some object detection, object tracking, and many other ML models that we have. And these signals goes to the reporting pipeline, which the data is where the data is processed, and the output goes either to the dashboard or to some alerts and notification, as we can see in the hotel use case. Now, this is the inference pipeline. And what is missing here is the training pipeline. So usually we start working with data, we do some exploratory data analysis, we first want to understand the data and understand the business problem we are solving. After that, we are applying some data processing, feature engineering, and then after that, there is a training, validation, and when we are happy with it, we deploy that model to the inference pipeline into production. Now, this is the whole pipeline, but how can we experiment in this pipeline safe and make sure that everything works as it's supposed to? One of the basic strategies to do is to separate on environments. You will have some isolated environments, dev, stage, and prod. In the dev, data scientists play around, they experiment, they play with the data, prototype some models, do some training, experiments, etc., without affecting the business critical environment such as production. And when the data scientists are satisfied with their work, they promote it to the production through the transitioning environment called stage. In the stage, we need to be sure that everything works exactly as it should be. When we are talking about promoting the work from the dev to production, we usually think on, in the machine learning world, we usually think on the two things. One is model promotion, where we do almost everything in a dev environment. So data scientists explore, train, experiment, blah, blah, blah. And when they're satisfied with it, they take the model artifact and promote it to the production for serving. This is easy to understand. It is a lot cheaper, but it can be error prone. The next thing is to promote the code itself. So you develop code on the dev environment, you train some model, you experiment with it, but when you're satisfied with the work, you actually promote the code, which in fact means that on the stage and on the prod environment, you will retrain your model again. This enforces reproducibility of models, and it makes sure that everything works just right, just as it should be on each and every stage. This code promotion thing is more expensive, of course, because if you have a bigger model, you need to retraining several times until it goes to the production. But it also makes sure that everything is tested correctly. How can we, if we take this computer vision system that we made, we use the code promotion thing. We used both, but it proved that code promotion worked better for our use case. So we have a dev environment in which we have some data set sample, or it could be a full production data set. And we also have our feature branches where we play, where we understand the data, where we train our models, make our experiments, and everything that goes with it. Also, we log all our experiments to the ML flow just for the sake of collaboration and reproducibility. These feature branches, when they are ready, they are promoted to the stage environment. And as I have said, the stage environment makes sure that everything is tested and everything works just as it should be. So I'm talking about full retraining of the model on some stage subset of data. I'm talking about a full testing of data pre-processing. Can we access the data from the DB? Can we write to it? What are we writing to the database? How training goes? Do we log the experiments to the ML flow? How it all goes down? Can we convert the model to desired format? And can we deploy it, serve it, use it? All kinds of let's say, integration tests. When we squeeze the soul out of our code and the model, then we are ready to move to production. In the production, everything happens just the same as in development. But we are training the model and doing all kinds of pre-processing on the live production data. When model is trained, we log all experiments and all parameters to ML flow. And after that, we just don't put it to serving, right? We need to make sure that it actually works. We need to compare it, to evaluate it, and compare it to the currently running model. If you can also deploy A/B testing as well here, just depending on your use case. And when we are sure that model performs just right, then we can either push a button or have that process automated. And that would mean we are pushing the model to be used in the inference, and it can be an online inference for REST API or TensorFlow serving with gRPC protocol or elastic inference or whatever you would like. Also, there is a batch inference for historical data. At the end, this is the pretty much complex system. It took quite time to build by ourselves. But the benefits are that we started doing the experimentation and all the model life cycle. We made it shorter. We were able to provide the value before because we have experiments run, and we weren't afraid that if we change something, we will break the running production setting. And our next step here would be to actually go the step further and deploy on the devices. Our sensor is working on the Jetson devices, and there is a good opportunity to actually, when we train our models, to pack it and using AWS IoT services to put it on exactly on the devices and to do inference right at the edge. This is something that we would really like to do, and I hope next year or some of the next years we will talk about our experiences with this one. And I would really like to thank you for this talk, and if you have any questions, please don't hesitate to ask me.
Can I start first with a question before I ask, because we have like 7-8 minutes. So what actually happens here? You get those images, and then how do you alert whoever is to be alerted? How does it work?
So we have a sensor that constantly uploads the videos.
And he recognized, for example, the lady in the red dress. It recognized her, and it keeps that
Yeah,
information.
it detects people and then assigns some ID to each and every bounding
So
box
this is
here.
ID 44, as it says.
Yeah, and in this case, there are too many people, so they are switching their IDs. But basically, each person has its own ID, and then using some computer vision techniques, we are tracking these people around. So when someone with some certain ID is here for X amount of minutes, for example, imagine that this is the building hall and we want to catch some criminals, then after several minutes, if the same person is here, then we trigger an alarm, take the snapshot and send it as a message to authorities.
So what is the format of the message?
An image, annotated image with the text.
So and the text is created by a computer saying that this person
that person stays here for X amount of time, and here is the image to confirm it.
And whom are you sending the image?
Depending on the application. For example, in the hotels, we were sending it to the attendants.
Okay.
That they are on the shift at that moment. In the Bronx, we sent it to the authorities.
Directly, I mean, to police or to...
Yeah.
So
police
directly
officer.
to them.
Yeah.
So was it difficult to establish that system?
I don't know. I wasn't in charge of making all regulatives that work, but we send it to the police officers.
Okay, thanks. Any questions? 2, 3. Oh, great. Can we get a microphone? Let's get it here first. Sorry, did you have a question? Sorry, I didn't see you.
Interesting application. However, do you consider data privacy with the participant? How do we, if we are really going for a commercial version?
So I understand. Thanks for the question. So the application is deployed where everyone gave their consent for the recording. And right now you're being recording here as well. So in the case of the hotels, that is in hotel policy that provide the cameras and to do recording. At the end, if you are just looking, well, some customers just want the dashboards, and in the dashboards you can't really backtrack to the people because it's just a bunch of numbers, how many people there are at the moment, how long people are staying there, what they're using, but you can't actually backtrack to actual and pinpoint the actual person.
The next question was here in the first row.
Hello, my name is Nicola. I'm data scientist. I'm interested, you said about interaction between the people that you're also measuring. How do you say that two people are interacting? Is it based on the intersection over union between two bounding boxes and the time they're spending in one place, or how do you decide? Are they interacting or they're just independently standing onto each other?
Well, we have several experiments on that. We are detecting both the people and the furniture. And one of the experiment was to use intersect over union and the calculated time of the intersection and everything else. And we also try to use the signals from person pose if the person is sitting or standing, and to track if there is a movement. So if there is a movement and person is standing, then he's just passing by probably the equipment. And we also have the additional classifier on the furniture to say is it occupied or not. And combining all these signals and doing some experiments, we made it work, although there is always room for improvements.
Thank you.
The next one was... Okay, there's another one and there's another one. Yeah, there first and then on this side.
Thank you for the great talk. I was wondering, are you also maybe estimating different features of this person, like sex or age or something like that?
Not yet.
Are you planning to, maybe?
Maybe.
Okay, thank you.
Here. Okay, we got the microphone.
I was curious about your model training in the deployment prod environment, how you call it. Would this be like just training the model that's already been selected at the experimental stage? Or like you do the full model selection with hyperparameter
full model.
tuning? Why?
Because we want to reinforce the reproducibility, and also we are training the model on the full data set in the production. You know that we in the dev, we usually don't train on a full data set the full time. We just want to prove that something might work. And in the stage, we have even less data set to train for. We just want to prove that the process of the model training, model testing, deployment, inference works. And in production, we are going with the full training and then test that model properly to see how it works.
Well, it seems like a little bit of a redundant process, isn't it? Like you do everything 3 times.
That's the thing with the code promotion. You're actually promoting the code, and then you provide a way to reproduce your tests across the environments and to test it. The different thing is the different pattern called model promotion, where it might have sense for some bigger models. Like, for example, for this one, for the object detection, you want to train it, experiment it in the dev environment. And when you're satisfied with it, you take the model artifact and just use it in production. That is cheaper and has less redundant work. But in such system, there is a lot of things going around the model, and you need to make sure that every piece that depends on the previous one works correctly. And that's why we have the separated environments.
So just one last question. Why are you doing, what did you see previously? Which problem did you try to solve by kind of staging it by code staging, in a sense?
We wanted to solve the thing that when we do something on the dev, which is a dev environment, the things might break, you experiment with all kinds of technologies. When you do something in the dev that actually works in the prod without less fear that you will break something. The pipeline is complex. It has object detector, object tracking, and all kinds of subsystems and glue code that are using the object detector. And through these stages, we test everything together until we go to the production.
Thank you. Any more questions?
Hi. So I'm interested about the latency in the inference phase. So how long does it take from the image to upload to the cloud and then do the inference part? Because you're probably doing the tracking, so you need the frames from the previous seconds.
The initial latency is 5 seconds. 5 seconds to go to the cloud. And then when it goes to the cloud, the one frame is processed in less than a second. It's hundreds of milliseconds or something like that.
Thanks.
And yes, another one.
So my question is similar to previous one. So you track metrics during inference time, and I wonder what kind of metrics you track, if it's possible to disclose, and also about latency as well, because it's a real-time result generation. So are you tracking metrics like backwards, like historically, or it's like also real time?
Yeah, for the inference time, so this is one metrics. We also measure the throughput. How many frames can we process in a parallel for different spaces? And also we monitor the quality of the image itself. It could be all dark or something might happen to the sensors. Then we also need to alert that system doesn't work as expected. And what was your next question?
It was about latency.
No, you covered it.
Okay.
So it may happen that you gave alert to system prediction, but after that you got from your metrics result that something was actually wrong with your system, right? So it can happen.
Yeah.
Okay.
Of course. And we have also a mechanism to reprocess all the data from the last month or last year or so. And then we are doing it in the batch processing. That's the different pipeline here, but it also do the similar steps just without the notifications.
Well, I could use the system to recognize if somebody is raising a hand. Can you provide that?
Of course.
Good. Okay, so there are no hands more as I can scan. Stanko is not seeing any other either.
No, I'm not wearing glasses, so I hardly see anything.
So that was it, Stanko Kuveljić and his presentation, and I'll see you back in 12 minutes actually.